Hi, in this particular session, we are going to talk about something called Einstein's relations. Before going to Einstein's relations, let us just understand and recap what is absorption. What is absorption? It's basically when you had two energy levels. Lower one was having energy E1, upper one was having energy E2. Actually, the atoms in lower energy state having energy E1, the atoms in higher energy state having energy E2. Abhi, what happens is when a photon strikes on any one of the atom having energy exactly equal to E2 minus E1, this is very important. Photon strikes having energy exactly equal to E2 minus E1, ये एटम वो एनर्जी अब्सॉर्ब करेगा, दैट इज व्हाई इट इज कॉल्ड अब्सॉर्प्शन, और वो एक्साइटेड स्टेट में जाएगा, तो इधर एक और नया एटम आ जाएगा और ये इधर से चला जाएगा. दिस इज समथिंग दैट हैपेंस इन अब्सॉर्प्शन. Energy of the photon has to be equal to E2 minus E1. Let's understand second case. But before understanding second case, let's understand that the number of atoms absorbing photons per second per unit volume ये किस पे डिपेंड करेगा. इसको हम अलग अलग लैंग्वेज में ऐसा कहते हैं कि रेट ऑफ अब्जॉर्प्शन ये किस पे डिपेंड करेगा. रेट ऑफ अब्जॉर्प्शन मतलब कि कितना अब्जॉर्प्शन हो रहा है पर सेकेंड पर यूनिट वॉल्यूम, कितने एटम्स ऑब्जॉर्व कर करके एक्साइटेड स्टेट में जा रहे हैं, किस पे डिपेंड करेगा. लॉजिकली, इफ यू थिंक लॉजिकली, द आंसर immediately is in front of our eyes. If the population here in lower state is n1, the population here in upper state is n2. What is population? Again, let us define that word. Population means ION. Population means number of atoms per unit volume. In that particular state, मतलब E1 स्टेट में N1 एटम्स है पर यूनिट वॉल्यूम, E2 स्टेट में N2 एटम्स है पर यूनिट वॉल्यूम. पर यूनिट वॉल्यूम का मतलब क्या है कि बड़ा सा ऑब्जेक्ट है, ऑब्जेक्ट इज वेरी बिग, उसमें से हम एक पर्टिकुलर प्लेस पे एक छोटे से वॉल्यूम की बात कर रहे हैं जिसमें ये सब हो रहा है, पूरे ऑब्जेक्ट की नहीं. दैट्स व्हाई इट इज नंबर ऑफ एटम्स पर यूनिट वॉल्यूम, दैट इज कॉल्ड पॉपुलेशन. एंड N1 is population of lower state. Logically this rate must depend on n1 because जितने ज़्यादा n1 होंगे उतना ज़्यादा particles will absorb. अब एटम्स इधर तीन ही है मान लो, और इधर से आप कितने भी फोटोन्स डालो वो तो तीन ही ऊपर जाएंगे, बट इधर अगर 3000 एटम है, इफ देर आर 3000 एटम्स हियर, then those 3000 will go. If there are 3 lakhs, then many of them will go, so that definitely depends on n1. That is the first thing. If the atoms are more and more, the more and more atoms will go up. Second thing, on what will it depend? This rate of absorption means more and more atom going up. What should it depend upon? Immediately you will say that the answer is photon also. So it also depends on photon. The photons which are coming, the density of photons. We call it density of photons having frequency nu is given by rho of nu. It's called density of photons having frequency nu. Having new frequency. This is called nu. It is not v, it is nu. तो डेंसिटी ऑफ फोटॉन्स हैविंग न्यू फ्रीक्वेंसी, अगर जितने ज़्यादा फोटोन डालोगे, अगर इधर 5 ही पार्टिकल है और आप 50,000 फोटोन भी डाल दो तो भी 5 ही जाएंगे. दैट मीन्स रेट इज डिपेंडेंट ऑन दोज 5 पार्टिकल्स, नंबर ऑफ पार्टिकल्स इन ग्राउंड स्टेट. सेकेंड थिंग इज, इधर अगर 5 लाख पार्टिकल है बट फोटोन आप 5 ही डाल रहे हो तो 5 ही ऊपर जाएंगे ना. दैट इज द पॉइंट, दैट इट इज ऑल्सो डिपेंडेंट ऑन रो ऑफ, दैट इज कॉल्ड डेंसिटी ऑफ इनकमिंग फोटोन. Density of incoming photons, if they are more absorption, less absorption, that is the basic rule. And to remove this proportionality constant, to remove this proportionality sign, we introduce a constant which we call b12. Since the particle is atom is going from 1 to 2, it is called b12 n1 rho of nu. So this is basically the rate of absorption. This is basically called the rate of absorption. You can name this equation 1. Second thing, it is called spontaneous emission. What is spontaneous emission, by the way? Spontaneous emission मतलब कि the particle is already in the excited state and it immediately comes down. That's why the word spontaneous. It immediately comes down, emitting a photon. That's why it is called emission. Here it was absorbing a photon. Here it is emitting a photon. Spontaneously comes down, emitting a photon. That's why it is called spontaneous emission. So स्पॉन्टेनियस एमिशन, अगर इसका एनालॉजी देखना हो तो ऐसा कि आप जमीन पे और आपने एक जंप मारा, जब आप जंप मार के एक हाईएस्ट पॉइंट पे थे उस टाइम पे यू वर इन द एक्साइटेड स्टेट कंपेयर टू ग्राउंड, बट उस जगह पे आप ज़्यादा टिके नहीं, यू इमीडिएटली केम डाउन. तो वो जो इमीडिएटली केम डाउन, दैट इज कॉल्ड स्पॉन्टेनियस एमिशन. जो भी आपका एनर्जी था वो आपने एमिट कर दिया. सो द एटम इज हियर, इट कम्स डाउन एंड एमिट्स अ फोटोन हैविंग फ्रीक्वेंसी न्यू, and that relation is given by this. वो जो फोटोन आता है उसका फ्रीक्वेंसी न्यू होता है और वो न्यू एच न्यू इक्वल टू E2 माइनस E1 जितना होता है. अगेन द पॉपुलेशन हियर is N1, N2 in 2 state. E1 state the population is N1. What does this rate depend upon? Rate of spontaneous emission, RSP. What does it depend upon? Let's keep it proportional. You will immediately say कि जितने ज़्यादा atoms E2 state में होंगे उतने ज़्यादा नीचे आएंगे. That it depends on N2 only. Now incoming photons are not required for this process, so it is not necessary, but more and more photons will be there in N2, more and more will come down, more and more atoms will come down emitting photons. So this rate of spontaneous emission is proportional to N2. Therefore when we remove this proportionality constant, we remove this proportionality sign, we introduce a constant. Now this time you are coming from state 2 to state 1, so we call this constant as A. State 2 to state 1, A to 1 and 2. So this is called rate of spontaneous emission. Now I want to make sure that you understand the difference between A and B. जहाँ भी फोटोन का जरूरत पड़ता है ना, एक्सटर्नल फोटोन का, उधर अपन B एज अ कांस्टेंट लेंगे, और फोटोन का जरूरत नहीं पड़ता उधर अपन A एज अ कांस्टेंट लेंगे. बाकी स्टेट नाम इज अकॉर्डिंग टू 2 to 1 or 1 to 2. So what is B12? It is also called, B12 is a coefficient. It is called Einstein's coefficient because Albert Einstein gave this theory, entire theory. So it is called Einstein's coefficient of spontaneous, not spontaneous, I am sorry, Einstein's coefficient of stimulated absorption, because you are stimulating the atom What is stimulated absorption? Stimulated absorption मतलब आप वो एटम को स्टिमुलेट कर रहे हो ऊपर जाने के लिए. You are providing some external stimulation or external trigger. That's why this is called Einstein's coefficient of stimulated absorption. Now this guy is called Einstein's coefficient. Spelling might be wrong of Einstein, you just correct it on your own. Einstein's coefficient coefficient of spontaneous emission. This is Einstein's coefficient of spontaneous emission. Then there is third guy. Third guy's name is stimulated absorption. Stimulated emission. In this process, what do you do? Just quickly recapping things. In this process, you have two energy states. The atoms are already in the excited state, but those states are called metastable states. They are called metastable states. Energy level is still E2, E1. There are some atoms here also. Population here is N2. Population here is N1. These are metastable states. What are metastable states? जैसे हमने जंप मारा था तो वो जो स्टेट था ना वो स्पॉन्टेनियस नॉर्मल स्टेट था, मतलब स्पॉन्टेनियस एमिशन हो गया। बट मेटास्टेबल स्टेट्स आर लाइक फ्लोर्स, कि पहला फ्लोर, दूसरा फ्लोर, तीसरा फ्लोर, चौथा फ्लोर। अगर आपका घर ही चौथे फ्लोर पे है देन दैट इज अ स्टेबल स्टेट फॉर यू, दैट्स व्हाई दे आर कॉल्ड मेटास्टेबल। इसमें जैसे तुरंत पार्टिकल नीचे आता है, इमीडिएटली इट कम्स डाउन। हियर इट डज नॉट हैपन, इट डज नॉट immediately come down. So what are the metastable states? They are specifically the states for which the particles do come down, but you have to provide some external trigger. It means that if your house is already on the fourth floor, you don't want to come out of your house, but if you are hungry and you have to buy some food, you have to come down, and that hunger is the trigger, some external stimulation. So in this case, that stimulation is there, your friend calls you to come down, that is external stimulation. So you provide a photon having energy h nu equal to again E2 minus E1. Then that photon makes this atom, compels this atom or triggers this atom to come down and then emitting two photons. तो एक photon तो जैसे नीचे आया वो emit होने ही वाला था, but second photon is this. So this one emits two photons, h nu, same frequency, same energy, equal to E2 minus E1. So these are the processes of absorption, spontaneous emission, and stimulated emission. Now you can immediately think this rate of stimulated emission should depend on what? It should depend on, of course, the population. More and more population, more and more particle will come down, and more photon density, incident photon density, more and more particle will come down. More and more triggers will be there, मोर एंड मोर पार्टिकल्स विल कम डाउन। इधर अगर एक ही फोटोन है तो एक ही नीचे आएगा, बिकॉज आपको सिर्फ भूख लगा है तो एक ही बार नीचे आओगे, ठीक है। पर कोई बहुत सारे दोस्त आए आपकी पूरी फैमिली के, एंटायर फैमिली कैन कम डाउन, राइट। सो दैट मोर एंड मोर ट्रिगर्स, मोर एंड मोर पार्टिकल कैन कम डाउन। so it depends on incident photon density, and if more particles are there, anyways more particle can come down. इधर अगर दो ही लोग रहते हैं फिफ्थ फ्लोर पे तो दो ही नीचे आएंगे, बट इफ देर आर 50,000 people on the first floor, approximately, like just assume there are 50,000 people on the first floor, all of them will come down. This is the idea. So rst is proportional to n2 into rho of v. Therefore if you remove this proportionality, what you have here is a constant which we call a constant b, because now you require photon b coming from 2 to 1 and to rho of nu. So this is called stimulated emissions rate of stimulated emission, and again this b21 is called Einstein's coefficient for stimulated emission. Yes, you guessed it right. This is called Einstein's coefficient of stimulated emission. So this is end of the basic story. Now in the next video we will see how these three are related, these three coefficients b12, a12 and b12 in the next video. Till this point it should be clear. If you have any questions you can always ask me.